Hi everyone, here is chapter 11, section 6, segment relationships in circles. So all the things that we've talked about in chapter 11 so far have been about the angles in or around a circle, right? So like central angles, inscribed angles, and then there was a bird beak, floaty angle, right? So a lot of what we're going to look at today, the pictures will look familiar, but we're going to be focusing more on the segments or the portions of the chords, or secants or tangents, instead of looking at the angles. So for example, we're going to look at this first theorem, the chord-chord product theorem. And here's what it says. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of the chords are equal. Okay, so that's lots of words, but basically here's the little summary. If you have a floaty situation, right? This is floaty because the vertex is inside the circle, not at the center, not on the circle. The following is going to be true. CE times DE is going to equal BE times AE. Or I guess I can say it in the order that it shows on the actual conclusion here, which says this red portion, AE times BE, is going to equal CE times DE. So the red times the blue equals the green times the purple. Let's try to apply this in our next, or in our first example. Example 1, applying the chord-chord product theorem. So we're going to find the value of x by applying the theorem we just read. This picture may be a little bit confusing, but just to clarify, JH is what x is. Okay, so let's take each portion of the chord and do product. Product of the two equals the product of the other two. Okay, so x times 14, the product of x and 14 should equal the product of the other two, 7 and 10. And notice 7 and 10 are part of the same chord, and 14 and x are part of the same chord. Okay, so let's simplify this. 14x is equal to the product of 7 and 10. We divide by 14 on both sides, and we get that x is equal to 5. All right, so try this next one, pause the video, and resume when you're ready for the answer. Okay, I'm going to assume you've worked on that OYO, and here's the answer. Okay, so 8 times x equals 6 times 5. You work that through, and x is equal to 3.75. The next slide is a repeat, so skip that. And let's look at this one. So a secant segment is a segment of a secant with at least one endpoint on the circle. An external secant segment is a secant segment that lies in the exterior of the circle with one endpoint on the circle. Okay, this is very wordy, but here's what is important to notice. This picture right here is basically bird's beak, right? Okay, and in this bird's beak, we have segment PM and NM. Let's take a moment to notice what these are. So PM is the entire secant, this whole piece, right? Secant segment. And then NM is that outside piece. It's like the beak part, right? Okay, now let's look at the next two sets, KM and JM. KM is the secant segment, so the whole part, and then JM is the beak part. Okay. Let's look at the next theorem. It all relates to the picture we just looked at. So the secant-secant product theorem says, oops, sorry about all that. Okay, so here's the theorem. If two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. Okay, so this is very wordy, but here's one way to sort of skim this down. Here, whole times outside equals whole times outside. So what that means is this whole piece, AE, times BE is equal to this whole piece, CE, times DE. And if you want to relate this to the whole bird's beak situation, it's whole times bird's beak equals whole times bird's beak. So I'm going to jot that down over here. I'll just write beak equals whole times beak. Okay, so in the picture, it's going to be AE times BE equals CE times DE. So let's see how this works in a problem. Find the value of x. Okay, so this is clearly a bird's beak situation, right? We've got holes, we've got beaks. Let's start off with this. So what's the entire length? And I know it's tempting to multiply them, but think about this. What is the length of DE? It would have to be the sum, right? 9 plus 7. Okay, so just as a reminder, this was our formula. Whole times beak equals whole times beak. Okay, so the whole entire DE is 16. The beak portion, the outside, the exterior, is 7. And now let's look at the other one. How do I express the entire length of GE? And I know it's super tempting to say 8x, but that would be multiplying that, right? So we have to use addition. So that's the entire length. And what's the length of just the outer part, the beak? That would be 8. Okay, so then we're just going to clean this up. So you can use your calculators, obviously, if you want to. 16 times 7, we get 112. And then this guy here is going to distribute. So we have 64 plus 8x. Oops, I did not mean to write that in blue. Let me fix that real quick. Okay. Let's continue to simplify. So we'll subtract 64 on both sides. So we have 48 is equal to 8x. We divide by our coefficient on both sides. And we have x is equal to 6. And done. All right, so go ahead and try the next OYO and then resume when you're ready to check the answers. Okay, now here's the answer. There we go. Okay, a tangent segment is a segment of a tangent with one endpoint on the circle. Segment AB and segment AC are both tangent segments, right? So they touch the circle at exactly one point as any tangent would, and they stop outside and they meet out there, right? Also reminds me a little bit about Party Hat. Remember Party Hat, where we said that these segments are congruent? Yeah. Let's see. If a secant, so this is the secant tangent product theorem. It's basically bird's beak with a modification. And the reason why it's a little bit different is because, see, this part's the same as any old bird's beak, but this part is not. Okay, so I'm going to read this part here. If a secant and a tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external segment equals the length of the tangent segment squared. Okay, so check this out. It's whole times outside equals tangent squared. And here's what's happening. So just like before, it's, sorry, one sec. Okay, it's whole times beak. But this time there's no whole in beak. It's just beak, right? So it's going to be whole times beak equals beak times beak. So basically, AC times BC equals DC squared. So when you have a secant tangent situation, it'll be whole times beak equals beak squared. Or if this is easier, you can do it this way. So here we go. We look at this problem. It's clearly a beak, right? That's a bird's beak. So let's see. Whole times beak. So the whole is 15 plus 5 plus beak. I'm sorry. That's not what I meant. Whole times beak, there we go, is equal to, there's no whole or, separate area, so it's just beak squared equals x squared. So 100 equals x squared, and we know that that means that x, algebraically speaking, numerically speaking, we've got x is plus or minus 10. But since x represents a distance, it can't be negative 10. So we're going to discard the negative and say, well, x has to be positive 10. All right, and that's where this lesson ends, and you're going to go straight to your problem set, and keep in mind that there are 8 problems on your problem set today, and there's 2 pages. Your quiz that's coming up on Monday is, you can prepare a cheat sheet on a regular piece of paper, like printer size 8.5 by 11 paper. Everything must be handwritten, and you can write whatever you want on it. You can use the front and the back if you want, and of course I'll approve it before you use it. Any other questions, you can ask me when I see you next, or send me an email. Let me just make sure there's nothing else. Oh, and the project, please don't try to turn it in today. I'll take it from you next class, okay? Have a great day. See you soon. Bye.